Hello everyone, this is Mohammad from the Department of Chemical and Biomolecular Engineering at Clarkson University. I will be presenting our project titled Advancing Sustainable Fertilizer Production through Plasma-Enabled Nitrogen Fixation. The project reveals the interconnection between plasma chemistry and gas-liquid mass transport in the generation of plasma-activated water, a nitrogen-rich liquid fertilizer. Nearly every meal we consume depends on one essential element, that is nitrogen. It is needed for the synthesis of different biological molecules like amino acids in protein and nucleotides in DNA. Although the air surrounding us is about 80% nitrogen, humans and plants cannot consume it directly. For over a century, we have relied on the Haber-Bosch process to produce ammonia, which is then used to make different fertilizers. This process takes nitrogen from air and forces it to react with hydrogen separated from natural gas under extremely high temperature and pressure to make ammonia. Although effective, the process has several problems. For example, it is extremely energy intensive and consumes about 1 to 2% of global energy production. It also relies heavily on fossil fuels. There are also some logistical challenges. The fertilizer industry is highly centralized, meaning fertilizers need to be transported long distances, often over 1,000 miles, to reach different farms in places like the New York State. This increases the end user cost and also emissions. Any disruption in this pathway can break down the whole supply chain, creating a shortage of fertilizer for the crops and hence the food for us. At the same time, commonly used fertilizers are not directly usable by the plants. They must first be broken down into different forms like nitrates and ammonium by bacteria in the soil. This delay leads to significant nitrogen losses through leaching and other processes. It creates inefficiency in the field level and also contributes further to environmental pollution. These challenges raises the need for a more sustainable approach. Plasma, more specifically plasma activated water, has shown great potential for this shift. Plasma, commonly known as the fourth state of matter, is a mixture of ions, radicals, excited species, and neutral molecules at high energy. About 99% of the visible universe is made of plasma, but it can also be generated artificially using a controlled electrical discharge in a gas, similar to lightning. In air plasma, high-energy electrons break apart stable nitrogen and oxygen molecules, leading to the formation of different nitrogen oxides in the gas phase. In presence of water, these oxides can be dissolved into the liquid phase, creating a solution rich with nitrogen compounds, including plant-available nitrate and nitrite. This approach allows fertilizer to be produced directly on the farm, reduces intermediary inefficiencies, and eliminates the need for any transportation. It lowers the emission and cost and increases resilience especially for small and remote farms. In addition, plasma activated water has shown great potential to enhance seed germination. It improves nutrient uptake and helps suppress plant pathogens. In my research, I have been working on developing and optimizing a plasma spinning disk reactor to achieve high nitrogen yield in plasma activated water while minimizing energy consumption. Rotation of the disk helps create a fast moving thin liquid film that enhances mass transport of the reactive oxygen and nitrogen species. We have been investigating how different operational parameters and modes impact the efficiency of nitrogen fixation. I invite you to my poster and am happy to answer any questions about the process or the project. Thank you.